Hello, and welcome to FileCatalyst January webinar. This month, we'll be talking about how accelerated file transfers and how FileCatalyst can help with live sports production. My name is John Tkaczewski. I'm the president and co-founder of Unlimited Software, the makers of FileCatalyst products. I have with me this month Christian Charette, our director of software development. Christian has been involved very closely with the development of the features for live broadcasters within the FileCatalyst product line. And please check out our blogs. Both Christian and I write frequently on our blog usually about file transfer, but sometimes we always talk about software development or any other networking news. So yeah, check out our blog. There's always a lot of good articles there. So today we're going to be talking about, first of all, we're going to give you a quick introduction about accelerated file transfers and why FileCatalyst is, faster than or better than traditional methods. We're going to be talking about the challenges that live broadcasters, or it's not really just sports, but it could be any live event production has. Mostly we've built these features mostly around the sports venues. So we'll talk about the challenges, and then we'll provide you some solutions that we've built into FileCatalyst to help you with these problems with these problems with live sports production and FileCatalyst. And finally, of course, we'll show you a demo of how things look, so you have just an idea at least about how the software looks and behaves and what to expect. So what we do is we concentrate on large file transfer. And what's large files? Well, that's big data. That's big files, usually anywhere from few gigs up to terabytes. In most sports production events, we look at files at about 100 gigs. 10 to 100 gigs, that would be usually the norm in the live sports events we've seen. What we do is that we can transfer these files into anywhere in the world between 2 points, and where the transfer is always going to be as quick as possible. That means we're going to be immune to any network impairments such as latency and packet loss. What we've done, we've built our own UDP-based file transfer protocol. And the reason why it chose UDP is that UDP doesn't waste any time communicating between the 2 points. The data is sent and it goes as fast as possible. So let's first talk a little bit about TCP. Well, TCP has been around for a really long time. Without TCP, you would not have internet today. Almost everything you're doing on the internet today uses TCP. Protocols like web browsing, HTTP, sending out emails, FTP, SFTP, Samba or Windows file sharing. That's all uses TCP as the underlying data transfer. TCP is reliable. It works well, but as soon as you start introducing latency or packet loss or any kind of network impairments, TCP starts slowing down a lot. So what we've built a protocol based on UDP, which is much more leaner and faster, and then we've added the reliability and the congestion control into our application. So think of it as the reliability and congestion control now being handled by the application layer, which is FileCatalyst. Like this, we don't sacrifice any of the advantages UDP gives us, and we also provide the reliability. So if there's a packet gets dropped while we're transferring files, we retransmit that data and we can handle it. Same thing with congestion control. We will not. UDP is known for going super fast and being very aggressive and crashing routers. We don't do that because we actually have congestion control built in, so we can detect the maximum capacity of a link. So we always stay within the parameters of the connection, so your buffers don't overflow and your routers don't crash. So the important part is that when you transfer files with FileCatalyst, is that if the connection drops for any reason, we will automatically reconnect and resume transfers from that point where files stopped last time. So we don't have to start from the beginning. And we also do this in a very smart way that we actually, when we resume the transfer, we'll verify what has arrived and what has been sent, do a delta on the two, sorry, not a delta, but we'll do a MD5 checksum, and then we'll resume. So it's not a blind resume like you would see with FTP or SFTP. We will do an MD5 checksum, making sure that both parts are identical before we resume. So this guarantees that your data always arrives intact. So here's some speed gains that you would normally see with FileCatalyst. Here's in the transfer scenario from New York to LA. This is within continental US. Network is really good within within continental US. So a 10 gig file over 100 megabit line with round trip time or latency of 50 milliseconds. With FTP takes about 2.5 hours. With FileCatalyst it takes 14 minutes. So that's a gain of roughly 10 times. Now let's take this example to LA to London. Now we're going, we have to go across continental US, and then we have to go over the ocean. So now the distance has grown. Same 10 gig file with RTT now of 250 milliseconds, because now we're going further. This is how long it takes on the internet to move one packet of data from LA to London. Now FTP will take 12 hours and 15 minutes, while FileCatalyst continues going on 14 minutes. So this is a 53 times improvement. Now, of course, if we have no latency, so let's say we're transferring files from one computer to the next, and computers are next to each other, and our RTT is 0, then FTP would probably be also around 14 minutes, just as FileCatalyst. So for local transfers, the improvement is not as much, but as soon as you start going overseas or over wider geographical locations, then the improvement becomes bigger and bigger and bigger, which is perfect for live sports production, because events are usually all around the world. And for example, this year we have Olympics in Sochi in Russia, we have World Cup in Brazil, and we have, actually I think the next Olympics are also in Brazil. So Brazil is very lucky this year. So you can't always move your studio and your staff. You can't always build a new production studio and your staff in all those events. It becomes expensive. And transferring these files into your central studio, where you can actually work on the files with all your equipment available to you, it was much more. It's much less expensive and much easier to do. So sending just one server with some storage is a lot easier than moving the entire editing suite. So another thing that live sports production usually handles is that you have files that are very big. We've seen files anywhere from 10 to 100 gigs with live sports. Of course, we can handle files bigger than that, depending what your workflow is or your file workflow is. We can handle files, up to several terabytes as well. And another thing we've noticed is that MXF files, which is a very common file production for sports production, is changes a lot from venue to venue, from event to event. And we'll be talking in a minute about what we've seen with these MXF files, but what we've tried to do is build a solution that is not specific to a specific encoding within the MXF files. We rather looked at the behavior of the MXF file on a disk and how it was behaving, and we tried to move the MXF. We move the MXF file from the disk to another disk instead of looking what's inside. So our solution is very agnostic to different type of encoding types you might have within an MXF file. Another problem with sporting events, especially the larger ones, is that you're going to have many camera feeds. So this will create many MXF files that you need to move almost in real time back to the studio. What we do over here is that you can create one single task within FileCatalyst hot folder, and that task will pick up any new feeds should they arrive on the storage. So you don't have to create many tasks for every single feed you want to do. You create one task, and the task will pick up any new content that needs to be moved to the studio. This greatly simplifies your management of these file transfers, because you don't have to create all these tasks individually, but we'll just rather use one task and everything gets created. We'll show this in the demo in a few minutes to illustrate how this works. And finally, another challenge is that the MXF, the files for live sports events usually grow. So as the feed comes in, this creates a growing files on your storage, and now you want to move that file. And growing files for live sports events are also not the same. One grow file is different than another grow file because depending on the format and the encoding, things will look different. So this is where what we looked at is we looked at the MXF as a container, and we wanted to really look at the behavior of the MXF of the grow file on the disk rather than what's the encoding inside or the metadata. So what we've noticed is that in most cases the file will grow in the tail. So that means as more data arrives from the camera, it gets appended to the MXF file, and the MXF file automatically grows. It's a very simple chase the tail type of scenario that exists. But we've also seen growing MXF files where it's more like a container. So imagine you have a preset size of the file, of the MXF file, and that file is then filled almost like a water pitcher with content. And then there's the question of the headers. Sometimes the headers will get updated every time something gets added to the file, and that will modify your headers. And your headers could be right in the beginning, but they could be also within the essence as well. You could have headers changing. So not necessarily headers mean right in the beginning. It could be all over the place. And another one is that as the file is completely written to the disk, then the headers are finally rewritten as the file is finalized. So we've seen both workflows with our system. So once again, the file changes in different places at different times. So we've built tools in FileCatalyst to handle these different use cases for growing files. And this is where I'm going to introduce, Christian is going to go in detail how we've built FileCatalyst features around these different growing file problems, and also how we handle, the other aspects of mode concurrency. So here's Christian. Please give us the rest of information. Thank you.
Make some minor modifications, add some features, once again, to make sure we can handle all sorts of conditions. So one of the things that we've done is when we were approached by multiple vendors or multiple clients, they asked us, listen, we've got a lot of files we're going to be generating, for example, sporting events like the Olympics. I need to make sure that you guys can handle multiple growth files and you keep tailing them, right? So the first thing is if you have a file which is growing, so you keep appending data at the back, we've got a feature called progressive. And so what we do is every single time we encounter a file, we'll take it, we'll follow it, making sure that we transfer the whole file when we first saw it. And then at the very end of the transfer, what we're going to do is we're going to check, has the file grown? If so, then we relaunch another transfer and keep appending to it. Essentially, we resume the transfer, and we keep doing this all the way up until the file is completely transferred or growth has stopped. So that's one of the first features that FileCatalyst offers, where, once again, we can follow growth files. The second one is because there's multiple growth files, one of the features we've introduced recently is to have multi-client transfers. And so what this is we'll scan a directory. If you've got multiple files in there, you can specify how many clients, in this case, how many growth files, or how many connections you would like to establish. And then what we'll do is we'll actually go in, the clients will look at each of the files and start following them if necessary. So you can have 3, 4, 5 growth files and then still have resources to pick up additional static content in your directory. And so what we can do is we can really handle, and this goes up to 100 clients. And so what happens is we're able to manage a lot of different feeds coming in, take them, send them across the wire, regardless of latency, and it works relatively well, very easy to manage because it's just one task in the hot folder that can be launched in order to manage them all.
Let me just, before we move on to the next slide, I just wanted to say if you have any questions during this webinar, please fill out there's a question box that you should see within the GoToWebinar window, and just enter your questions there. We'll handle them at the end of the presentation. Thank you.
Another issue that we encountered is while a lot of these systems are generating these high-resolution files, what they also do is they generate a low-resolution proxy file. This way, what happens is that the camera's doing the filming on the remote location. They have a smaller video they can send back to headquarters. The editing, the off-site editing studio can have a look at it and decide, yep, we need certain clips. So these proxy files are growing at a much, much slower rate than the throughput they actually have on site, for example, in the Olympic Games coming up. So what we've had to do is the software, as it was done a couple of years ago, would check the file, send all the data, but because it was sending the data so fast and the growth of that proxy file was relatively slow, it would look to the software like it was static. Data wasn't going in, so immediately, boom, it would fire off saying, yep, file is done, move on to the next file. And the proxy file, no, it's still growing. So what we've done is inside the software, we've enabled so that for dynamic files, what we can do is we can add a pause. So after you've transferred the file over, I want you to pause for a certain amount of time and then check to see if the file has grown. As this gives you a lot of flexibility, and it allows to make sure that if the file is really still growing, there's a very easy mechanism you can put into place, and then we can make sure we wait a certain amount of time. And for slow growth file, this works exceedingly well. Where's the mouse click? Aha. But we've also encountered some very strange behavior, I guess. From a file transferring perspective, what you normally expect for a growth file is data gets put in, and much like a log file, you expect the data only to be put in at the end. Media files, large systems that take it, compress the data, and then dump it into storage ready for transfer. What we've realized very quickly with some of our customers is that they were doing some strange things. One of them is, once again, after the entire file has been transferred, so we could be tailing the file now, and then at the very, very end, we need to go back to the header and we need to change a couple of bytes. And from a file transferring perspective, that really, for regular, if you use, FileZilla, you use another standard file transfer solution, what happens is, because if you're tailing the file, you've already transferred that first, megabyte, gigabyte of the file. So the headers have already been across. So if all of a sudden you go back and you change the headers, the transferring software kind of has no idea. And so it's waiting there and saying, well, listen, the two files don't match, even though I've transferred every single byte. So what we've done is we've put multiple solutions in place, depending on what your needs are. Each has their pros and their cons, in order for you to adapt to that kind of a scenario and handle it very eloquently. The first one is what we call, it's essentially we wait till the file is essentially stopped growing in order to transfer it. And so what happens is, when the files get received onto the remote SAN, what happens is they'll start writing the file, you start adding gig all the way until, I don't know, it reaches, let's say, 100 gigabytes in size, and then you go back and you look at the header. And normally there's a known time. It'll take, within a minute, the header will be changed, normally with basic statistics like metadata information, like the file, of the size of the file, etc. So if on the transfer you specify, listen, I want you to hold off, do not transfer a file up until it is at least 1 minute old. Okay? What this allows you to do is it allows the entire file to be written out to disk safely, then the headers get written, and then 60 later, boom, I kick off a transfer. So it means, of course, that when the actual file is written, we're not tailing it, but what it means is, from a networking perspective, we only send the file once, and we'll wait essentially until the job is done to transfer it out. So from a network utilization perspective, it's very efficient. The second,
actually, another aspect of this is when large files are getting copied to a network drive from another system. So let's say the network copy will be pretty fast because it will be local, but still these files are so big that it could take 5-6 minutes. So we don't want to start transferring these files as Windows is copying the file. We want to wait until the operating system finishes the copy before we start our tasks in the hot folder.
Yeah. The other thing that we can do is what we can do is, as you start adding to the file, we launch a transfer with tail the file. So as you're adding the file to disk, we're already starting to transfer it out. At the very, very end of the transfer, if you go back and you change some data, whether it's a header or halfway through the file, what we do is we can specify that we're going to wait, once again, a specified amount of time. It could be 5 seconds, it could be 60 seconds, and then we relaunch a transfer, but we relaunch it using deltas. Now, deltas is kind of an rsync scenario, and what this means is we look using a series of rolling checksums. So it's a lot of, people have gotten their PhDs trying to figure out how to do this stuff. What we do is we look at the binary of the files on both sides, and we actually check what has changed in the file from a binary. So it doesn't matter if, once again, they modified a couple of bytes in the header or halfway through the file. When we start transferring with the deltas, you have some calculations done on both sides, and then we can transfer exactly what has changed. And so in the case of, for example, a couple of bytes being sent in the header, once the file is transferred, we'll relaunch the deltas. Once the computations are done, we'll see, a couple of bytes need to be sent. Fire those off on the network. It's a little bit more computational, so there's a little bit more I/O, obviously, because you have to rescan both sides of the file after the transfer is already done. There's also, because a lot of checksums are done, it's a little bit intensive computationally. But from the networking side, very little resources is spent, and only the data that needs to be sent across is actually sent. So it's a very elegant solution, and it also makes sure that the data is there as fast as possible.
Okay.
So, and this is our upcoming hot folder 3.3.1, and from what you see over here is exactly what we've described. These are dynamic files, settings, features that you can enable, and you can actually decide, once again, what the rules are, how you would like the software to behave when it encounters files which seems to be growing and changing. So they're very, very easy to use, and this is what will be used in the coming weeks.
So here's just to recap how an accelerated file transfer, or how FileCatalyst can help with live sports events. First of all, you got very large files that you need to send over very, very wide geographical distances. This is where the accelerated file transfer part is helping. We've built the special rules to handle growth files for MXF, so we can accept almost any kind of a behavior from the MXF file, and we'll be able to send it progressively. We've built an extreme concurrency transfer feature. That means if there's more than one grow files or more than one camera feed, we will handle them dynamically, that everything arrives automatically, so you don't have to create 100 tasks for every single feed, but rather you can just make one task, and the task will pick up new feeds and transfer them over the wire. And of course you can control which one has priority, which one doesn't, as these files are transferring. So you might not be, for example, for Sochi, you might be more interested in hockey than another event, so you might give it more priority. And transferring, of course, the dynamic file sets, so growth files, as the files are being created. So these are some of the solutions we have within the FileCatalyst feature set. So here's Christian, can you go over here's a sample event of a FileCatalyst at a live sporting event. This was actually taken from Sochi. And Christian, can you just go over quickly the deployment, and then we'll go into the demo?
Yeah, so this is a partial kind of a deployment picture we have running. I guess in the coming few weeks we'll have this scenario live. And so what you see here is you have multiple cameras going in, putting data into a local SAN found in Russia. From there, a hot folder picks up the data, checks the data in the transfer cache. So we have a feature in the FileCatalyst called the transfer cache to make sure that the hot folder will only send the file once unless the file is changed. And so once a file is put into the SAN, we'll check, have we already sent the file? Is the timestamp changed? If so, yep, we take it. We pop it onto a queue internally within the task, and then from there on in, you have your multiple workers picking up the file and transferring it remotely. So in this case here, we can get up to 100 feeds that are coming in, being created by the broadcasters up in Russia, grab them, and then push them out to Europe or North America in a very timely manner, where they can then be taken, ingested within the broadcasting, whether it's to go on their website or to go live on the television feed.
So here we're going to show you some of the concurrent file transfer features and some progressive features right now. So Christian, please open up the, I guess it's VNC, right? That's what we're using? Yeah.
So what I have here is I've got a
the mouse over there.
yeah, I'm all right. So I've got a hot folder set up. Let me see if I can stretch the window out a little bit. I have a hot folder set up on a machine. I'm going to be talking to a server, and I've set up the configurations for the server much like we're having from North America to Russia. And so if I go in, for example, over here, let me see if I can, if I ping my remote server, so hold on a second,
You can take the mouse.
I've lost focus. There we go. 10.1.1.59, I believe. So I've got about a latency of about 150 milliseconds, which is probably what you get between New York and Russia at present.
I think it's a bit more, but let's not dwell on details.
And so what I have here is I have a hot folder, and I'll just kind of walk you through it. This is hot folder version 3.3, which is currently available up on our website. And what I have over here under the transfer, you can see that I've enabled the multi-client, so I'm going to be up to 6 streams going across. And so what the hot folder is doing constantly is it's scanning every 10 seconds. It's scanning the directory. It's scanning the directory, looking for work, looking to see if there's anything to transfer up. So I have what I'll do here is I'll just create a whole bunch of MFX files. I have a script to kind of do that, and I'll be creating them each at half a gigabit per second. So as soon as I fire this off, I can see over here that my files have arrived and they are growing. And then if I look at the transfer as it comes in, so what happens here is that my hot folder realizes, hey, I've got a whole bunch of files that are growing. I launch them, I start them up, and you can see right now that I've got 6 gigabytes or so. And so what the FileCatalyst software is doing is it's checking every half second to see if the file has grown, and then it transfers as fast as it can. So what I've got here is I've got a 2 gigabit link between the server and the hot folder, which mimics what a lot of customers have right now, going from Russia out to either Europe or North America. And you can see that I am following the data. Everything is coming in. The software is constantly checking to see if the file grows and is tailing it.
And can you just show the Linktrapy maybe? Linktrapy is the emulation software we're using between the 2 machines. So you kind of see here the data throughput. So you can see here that we're utilizing.
I'm utilizing 2 gigabits worth of data. It's a nice steady stream. No problem there.
And if you go back to the progress bar, you'll see that the progress bar is always chasing the end, but never quite making it to the end.
Yeah.
Because as the files are growing, the progress bar is always chasing the tail.
Yeah, and it'll grow until about, I think I set it so it'll grow all the way until about 30 gigs or so. And so the clients are all moving, they're all transferring, and they're all kind of balancing it out between them.
And you can see here that these are different MXF files. In our example, we're just using some sports names, but this could be, camera feed 1, camera feed 2, whatever you want to call it. And we didn't have to set up a specific task for every feed. Everything got picked up automatically and start getting transferred. And then you can drill down to any of these transfers and see what's going on in details. In fact, actually, you get quite a bit of details already here. But you can see here every transfer, what's happening with it. And you can really manage your system well between during transfer of growth files.
But what you see here is we're managing the 2 gigabit link without too much of a problem. And I think it's just about to wrap up. And that's it. There we go. The files are there. And we're done.
And now everything has been transferred.
Yeah, everything's been transferred.
Yeah. Great. So, I'm not going to already pitch here. It's just a little slide here what we do, but we do accelerated transfers. We specialize a lot within the broadcast space, especially with live sporting events or live events. And we've been around since 2000, the company. FileCatalyst as a product has been in existence since 2006. We have over 1,000 customers around the world using our software. And don't forget our monthly webinars. We always try to look for topics. If you have a cool topic you would like to hear, please get back in touch with us, and we'll most likely we'll consider it for the next release. So let's just go. Let's see if we have any questions. Let me just close this here. And pause questions. Do we have any questions?
No questions. We have a satisfied.
We have satisfied. So last chance to enter any of your questions. If you have no questions, you can always get back to us. You know how. Contact us via email or phone, or meet us at one of the trade shows, or our user forums. So thank you very much, Christian, for being with me this month.
It was a lot of fun.
And it's always fun to have you in the webinars. And see you next month. Thank you.